I want to give you some guidance here on the Laboratory Skills Lab. Now, the first thing you should probably do is read through the background. Now, a lot of people don't read through the background. They probably just want to get on the procedure and just go for it from there because they don't really want to waste their time reading. But you'll find there's a lot of stuff in the background that might be useful to you, especially some good clues about how to record numbers and things. So I think you should read through that and then get started on the procedure. So the procedure is here, and what we're going to do is we're going to measure some volumes. So what we're going to do is we're going to first of all get a beaker. This is all in the procedure here. And we go to materials, we get some water, and you can put as much water as you need to in here. And here it's going to be, I'm going to put 45 mils. It says between 40 and 50. So that goes in there, and then what you're supposed to do is zoom in on it, and you're supposed to just guess how much you think is in there. Don't worry about the fact you put 45 in there. But I don't know, you're looking at it, there's the 50 line, you know it's below the 50 line, so you know it's less than 50. But you really don't have a clue exactly what the measurement is. I'd say somewhere in the realm of 44, 43, something like that. I don't have a clue. It's not really a very good measuring device, the old beaker. So then what we're supposed to do is try an Erlenmeyer flask. So we put that here. Then we can pour it all into the Erlenmeyer flask. That's what I'm doing. And I zoom in on the Erlenmeyer flask and I take a look at what I have. And again, I've got these graduations here. There's a 25 and there's a 50. I know it's between 25 and 50, but I really got no clue as to exactly what the measurement is. But I would say, if I had to estimate, say about 40 mils. Again, I know it's 45, but I'm just being asked to measure what I think I see here. Then we take the graduated cylinder. Now, if you look at the background, there's a special place where they talk about significant figures and measurements. And they make this point about graduated cylinders. And they say that they have 1 mil subdivisions. Let's go ahead and pour the water in and I'll show you what I mean by 1 mil subdivisions. I guess the point I'm making here is when you zoom in on it, you can see that there are a whole lot of lines here. And here is 40 and here is 50 up here. But in between the 40 and 50, there's 10 lines. That means that each of those lines is worth 1 milliliter. So when I'm looking at it, see if I can zoom in any more than that. That's about it. That's the way I'm looking at it. That's a whole lot more accurate than anything that I was looking at over here with the beaker or the Erlenmeyer flask. Now the point they make here is that since it can be measured to 1 mil, you measure 1 decimal past that. If it was on the 45 line, you'd have to put 45.0 mils. And that's a whole lot more accurate than the 44 or 43 or 40 or whatever I was saying for the Erlenmeyer flask or the beaker, because now we've got an extra figure involved, a significant figure. So that's how you'd have to measure that with the graduated cylinder, because it is a more accurate device than the other two that we were looking at. Okay, back to the procedure. The next thing we're going to do is we're going to measure the mass of this liquid. Alright, so it asks us to get a beaker, a balance here. And then we're supposed to get a beaker. I suppose we can just use the beaker here and stick it on the balance. Alright, so that represents the mass of the beaker, and it says 185.000 grams. Now, that whole number is the mass. You can't just say, oh yeah, that's near enough, it's 185. No, it's not. It's 185.000 grams. If you look at the background and you go through the significant figure rules, that's these here, what you'll find is that trailing zeros at the end, are significant when there's a decimal point in the number. And that means that these matter for your accuracy. Now, if this was 185.001, nobody would have any trouble writing that down. Why would you have any trouble just because it's 000? It's almost like people feel the number has to be penalized just because there's zeros at the end. But no, that's not the case. So it's 185.000 grams. That would be the mass of the beaker. Now what it asks you to do is zero it. And when you zero it, it goes down to 0. It's not that the beaker's not weighing anything. Let's take the beaker off, we'll see what happens. See, it goes negative, and the reason it's going negative is because when you put it on, you want this to be 0 so that when you add something to it, like this water for example, then all you're measuring is the mass of the water. And again, it's 45.000 grams. You can't just write 45. Alright, so the next thing we're going to do is we're going to measure some solids. Let's go back to procedure. And to measure mass of a solid, and what it says, we zero the flask, and what we're going to do is we're going to get an empty Erlenmeyer flask and zero it. And what they're making the assumption here is that anything in an Erlenmeyer flask will have the same mass for the Erlenmeyer flask, and in this case it's 88.000 grams. And that's and then we're going to zero it. So notice again it went down to minus 88.000 grams. We're not interested in the mass of the Erlenmeyer flask anyway. So we'll go over here and we'll get a mass of a cornstarch sample here. And it automatically puts it into an Erlenmeyer flask for you. It's supposed to weigh the same anyway, the Erlenmeyer flask is. And anyway, that mass there, 30.000 grams, there's your mass of your cornstarch. And that's what you record. Now you'll repeat this process for the other materials that you need to record, but make sure you write them down exactly as they appear on the balance. Otherwise, you are not giving the number its full credit for its accuracy.